Before we begin, it's probably useful to take a look at page 954 and read about what conic sections are. But just as a quick overview, notice if you take a cone and you take a plane, which is basically an infinite 3D sheet of paper, or 2D sheet of paper, and slice the cone in certain ways, you get what are called conic sections. If I slice straight across, notice I get the circle. That little intersection is a circle. If I go at a slight diagonal, notice I get an ellipse. If I go parallel to the edge of the cone, I get a parabola. If I go steeper than that, it intersects the cone twice, and I get a hyperbola. So this section, we're going a little out of order because I think the parabola is probably the easiest one because it's the most familiar. So we're going to start on 9.3 with the parabola. So just a reminder of what we already know. So if we have a parabola, the vertex form is a times x minus h squared plus k. Or the standard form is ax squared plus bx plus c. General form, not standard form, general form. But either way, if a is positive, it opens upwards. If it's negative, it opens downwards. The vertex of this guy is hk, and the x-coordinate of the vertex is negative b over 2a. We're going to take it from a very different perspective. We're going to pretend we don't necessarily know, what a parabola is, because so far we've just basically said the graph of a quadratic is a parabola. But what does it mean to be a parabola? Well, here we go. Here's the first definition you'll have seen of a parabola. A parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus that is not on the line. So notice when I'm looking at this, every point on this parabola, if I draw a line to the focus and a line to the directrix, these lines are going to be the same length. Again, let's try it one more time. So notice these lines are going to be the same length. So any point that satisfies that is on the parabola. So the line passing through the focus and perpendicular to the directrix is called the axis of symmetry. The point of intersection of the parabola with its axis of symmetry is called the vertex. And notice that the vertex is basically it's halfway between the directrix and the vertex, right? So notice this distance and this distance are the same. All right, so first off, let's come up with the general equation of the standard form of the equation of a parabola. Let's just do it based on only the definitions. So let's just take a parabola. It opens to the right. It's centered at the origin 0, 0. And let's put the focus at p comma 0. So this distance here is p. Then this distance here would be p. And the equation of this directrix here would be x equals negative p. All right. So if we're setting up an equation, basically we know this distance, that line, and that line must be the same. So let's just go ahead and compute that. So d1, let's use the distance formula. It's going to be the square root of x2 minus x1, so x plus p squared, y2 minus y1, so y minus y. I'll just write that down, y minus y squared, even though that's 0. And that's going to equal square root. Now let's do the same. We're doing this line here. Now it's going to be x minus p squared. And then it's going to be y minus 0 squared. So let's go ahead and solve this out. So let's square both sides. And so the square roots basically just go away. X plus p squared plus, and then let me simplify that. Y minus y is 0, so 0 squared is 0. So I just get x plus p squared on the left side. So let me make that a little bit neater. X plus p squared. On the right side, we get x minus p squared plus y squared. Okay, now let's multiply it all out. So I get x squared plus 2px plus p squared equals x squared minus 2px plus p squared plus y squared. Notice I'm going to subtract x squared from both sides, so those go away. Subtract p squared from both sides, those go away. And I'm going to add 2px to both sides. So I get 4px equals y squared. And that right there is standard form of the equation of a parabola. And this is one that opens to the right. If I wanted to have one that opens upwards, I could go through the exact same thing, but it's going to have a slightly different equation. Basically, we're just going to swap x and y there. So the standard form of the equation of a parabola with vertex at the origin is, and this one is y squared equals 4px, and x squared equals 4py. So just swapping the x and y is whether it opens vertically or if it opens horizontally. And then also keep in mind, what is this p exactly? What does that represent? I think of that as the distance from the vertex to the focus, and the distance from the vertex to the directrix. So just kind of keep that in mind. P, again, is this distance right here. That is what P is. And if you just remember that, then everything becomes a lot easier. If you look in the book and things, they have a lot of different formulas to memorize. Realistically, if you know these two, and then you remember what P represents, then there's not much more memorization you need to come up with. All right. So let's find the focus and the directrix of the parabola, y squared equals 8x. So in this case, first ask yourself, does it open horizontally or vertically? So the way I keep track of it is x squared. All the parabolas we've dealt with up till now have been x squareds, and those were all vertical parabolas, right? They opened upwards or they opened downwards. So this one does not have an x squared, it has a y squared. So that's got to be one that we haven't dealt with. So that's going to open left to the or the right. And basically, if this is positive, it'll open to the right. If this were negative, it would open to the left. So I have a parabola that opens to the right. So if you want to think of it, I've got this scenario here. And remember, the formula here is y squared equals 2px. So what must p equal? Well, 2p must equal 8, so p must equal 4. So that tells me my vertex must be 4 to the right, my directrix must be 4 to the left. So this distance is 4, this distance is 4. And so the focus must be at 4, 0, because it's 4 to the right, and the directrix must be at x equals -4 because it's 4 to the left. The last rectum and graphing parabolas. So the last rectum comes in handy as well. The last rectum is basically the length of the line that goes through the focus. It connects the parabola going through the focus. And that is basically that 4p is going to give me that length. So this is 4p. So what that means is if I'm graphing y squared equals 8x, if I come back up to this one, if I was graphing that, I would know that this distance here must be 8. So I know this point would have to be 4, 4. I know this point right here would have to be 4, -4, because the whole length is 8, so I must be going up 4 and down 4 from the focus. So let's go ahead and do another example. Find the focus and directrix of the parabola given by x squared equals -12y. So again, it's x squared, so it's going to open up or down, and it's negative, so it's going to open downwards. All right, so notice, what's p going to be in this case? Well, 4p must equal -12, so p must equal -3. So that means it's going to open downwards. I'm going to go down 3. So if this is my vertex, I'm going to go down 3 to get to my focus, and I'm going to go up 3 to get to my directrix. So I've got y equals 3 there, and then this is the point 0, -3, and of course that's 0, 0. All right, now, how do I use the lattice rectum to graph this completely? Well, lattice rectum is the length of that is 12. So I'm going to go right 6, 1, 2, 3, 4, 5, 6. Go left 6, 1, 2, 3, 4, 5, 6. And then I'm going to draw my graph. Again, that whole distance from those 2 points must be 12, so half of it must go each way. So that's the quick way to graph them using the lattice rectum as well. So if we can find our focus, our directrix, and our vertex and use the lattice rectum, it's actually a pretty quick problem to do. So find the standard form of the equation of a parabola with focus 8, 0, and directrix x equals negative 8. So again, if I look at this, focus is right here at 8, 0. Directrix is over here at x equals negative 8. So my vertex must be halfway in between, so it must be at the origin. And what must P be? Well, if you look at it, what's the distance from the vertex to the focus? It's 8, so P must be 8. So it's just going to be y squared equals 4 times 8x, so I get y squared equals 32x, and we're done. All right, so here's a couple different formulas for the translations and things like that. But what I want you to think about is think back to when we first covered circles. When we had like the equation of a circle, remember, was x minus h squared plus y minus k squared equals r squared. And that had the center at h comma k. That's going to be the same thing here with parabolas. We're going to take our standard forms that we have up here, and we're going to replace x by x minus h and y by y minus k. And h and k will be the coordinates of our vertex. So I don't necessarily think it's very important to memorize these formulas. If you can remember the original unshifted formulas, if you can remember these two guys up here, which are not too bad to remember, then we don't really need to know to memorize these. We can if we understand what's going on, we don't really need to know anything in this chart. It's like this directrix is x equals h minus p, y equals k minus p. It ends up being a lot to memorize, and it's a lot of letters that make it overly complicated. So let's just kind of do it without any of that. I'm gonna do it all. It's all relative. So let's look at number 4. Find the vertex, focus, and directrix of the parabola given by x minus 2 squared equals 4y plus 1. Graph the parabola. So looking at this, notice x minus 2, so the x coordinate of the vertex is going to be 2. Y plus 1, so the y coordinate of the vertex is going to be negative 1. The x is the square term, so it opens up and down. P is positive, so it's going to open upwards. So, and also notice, what is P going to be? Remember, this number right here is represents the 4P. So if I have 4, and I know that that has to equal 4P, notice that gives me P equals 1. So again, just it might seem like a lot right now. Let's just go one more time. The vertex, x minus 2, so the x value is 2. Well, y plus 1, so the y value is negative 1. The coefficient here is 4, and that must equal that 4p component here. Even if you look at the more complicated formulas, that's the 4p part. So if that number is 4, then p must be 1. And that's all the information I really need to be able to graph the parabola or come up with the focus and the directrix and whatnot. Because I'm just going to plot that vertex to negative 1. There we go. P is 1, and it opens upwards, so I'm going to go up 1. This is going to be my focus. This is right there is my focus. And then I must be going down down 1 to get my directrix. So that's going to be y equals negative 2. Notice I didn't use any formula to come up with that. I didn't use this, y equals k minus p, although if I did, you'd notice it would work. It ends up being negative 1 minus 1 gives me negative 2. All I did was work from my vertex. My vertex was at 2, negative 1, and my p is 1, so I knew I had to go up 1 and down 1 to get to my focus and directrix respectively. Finally, what's the length of the lattice rectum? Remember, that's just that number there. So I'm going to go right 2 and left 2 because that whole distance is 4. Or sorry, I put those in the wrong spot though. That's got to be with the focus, not the vertex. So left 2 and right 2. And then I connect them, and there I go. Find the vertex, focus, and directrix of the parabola given by y squared plus 2y plus 4x minus 7 equals 0. Graph the parabola. So this one is not given to us in a nice standard form, so we need to put it there. How are we going to do that? You guessed it. We're going to have to complete the square. So let's go ahead, and I'm going to move the 4x minus 7 over to the other side. So I'm going to have y squared plus 2y equals negative 4x plus 7. Now I need to complete the square, so half of 2 is 1. 1 squared is 1, so I'm going to add 1. I'm going to balance it by adding 1 on the other side. Now this left side factors to be y plus 1 squared, and the right side is negative 4x plus 8. Well, we can factor out that negative 4, so I get y plus 1 squared equals negative 4x minus 2. So that tells me my vertex is at 2, negative 1. P is going to equal negative 1, right? Because this number here has to equal 4p. It's y squared, so it opens horizontally. P is negative, so it's going to open to the left. So let's see here. It says find the vertex, focus, and directrix of the parabola. Okay, so, and I just realized I didn't actually write what those were on the previous one, so I'll go back and finish that after we finish this one. So my vertex is 2, negative 1. My focus has to be, remember, P is negative 1, so it's my focus is 1 away, and since it's a horizontal parabola, my focus is going to be 1 to the left. If it helps, you can graph it first. So 2, negative 1. P is negative 1, so my focus is going to be left 1. My directrix is going to be right 1. So my directrix, I'm just going to call it D, is equal to x equals 3. And my focus, call it F, is just going to be, looks like 1, negative 1. Finally, my lattice rectum is 4 again, so I'm going to have 2 up, 2 down. And there's my graph. So similarly, we did all of the stuff for 4. I didn't actually just write it down. The vertex we said was 2, negative 1. The focus looks like it's at 2, 0. And then the directrix, it looks like it's at y equals negative 2. And I did label that on the graph. So, all right, so take 5 minutes and read the application section on pages 992 to 993. Well, basically one of the things that they say is if you look at a parabola, or in this case this is 3-dimensional, it's a paraboloid, what ends up happening is the focus ends up being where all the, like, everything that reflects off the dish would end up being. So like satellite dishes, flashlights, radiant heaters and things like that, those are all parabolic in shape, because if I have a satellite dish and here's my focus, how it works is if a signal comes in, it's going to bounce and go right here. Signal comes in, it's going to bounce and go right here. And so that's how satellite dishes work, is if you have a little bit of spread in your radio signal or whatnot, it takes all those radio waves and directs them to one spot that's going to interpret it all, which is, you know, where you put your sensor or whatnot, which is at the focus. All right, so there are very useful things with parabolas. You just look at any flashlight or anything like that, and you'd see how it comes in handy. All right, so an engineer is designing a flashlight using a parabolic reflecting mirror and a light source. The casting has a diameter of 4 inches and a depth of 2 inches. What is the equation of the parabola used to shape the mirror? At what point should the light source be placed relative to the mirror's vertex? So again, in a flashlight, the focus is going to be the light bulb itself. All right, so the casting has a diameter of 4 inches. So here's a little picture here. We got 4 inches from side to side. It's got a depth of 2 inches. So we got this graph right here. And we're trying to find the equation of the parabola used to shape the mirror. So notice the vertex is at 0, 0, and it opens upwards. So we've got x squared equals 4py. Right? So all we need to do is figure out what p is, and then we're good to go. So the equation, let's find out what p is. Well, how can we do that? Well, we got this nice little point here, 2, 2. So let's plug that in. This should be true for that. So 2 squared equals 4p times 2. 4 equals 8p. P equals 1/2. So my equation ends up being x squared equals 2y. That is my answer for the first part. At what point should the light source be placed relative to the mirror, the mirror's vertex? It basically, p is 1/2, so it should be 1/2. The point would be 0, 1/2, or 1/2 inches above the vertex. So that's kind of cool stuff, right? now you know why they have the shape that they, like satellite dishes and everything like that, have the shape that they do. And that's it for this section.